Um, in this short tutorial, I will discuss um, stress and stress. What is stress? Let's look at this member, and I applied force. One end, the other end is fixed. So the force is F. So due to the external force, there is a internal force. And the stress is the force per unit area. Area on a body that tends to cause its change. Now let's consider this object or this member that is a force, and on the both end, and there is, so this is a segment or section in the body. Now if I, due to this force, this entire cross section area of this segment, actually there is a pressure, it will generate a distribution. This force will be distributed to the entire body, for example in this plane. Now the stress is this force divided by area. The area means this area, this area. Okay. Now next, consider a object, 2D object. I applied force on both ends, and let's cut this object with a plane theta. Now if I cut this object, this, and this is my theta. Now this force is F, and it has two components. One component is perpendicular this plane, say this is F1, and other component is acting along this plane, F2. And if this is theta, this is also theta. Okay. So this F1 is normal force because it is normal to this plane. This plane F2 we call shear force, which is parallel, which is acting along the shear plane, this plane, and this F1 is acting perpendicular to this plane, shear force. Now, so F1 we can say F cosine theta and F2 F sine theta. So the stress can be divided into two types: normal stress, and the number two is shear stress. So the normal stress is caused by normal force. Shear stress is caused by shear force. Now in this example, let's find out what is the shear force. So the normal stress we define normal stress by sigma is normal force divided by cross sectional area. So the normal force is say, F1, and now okay, say area. Now area is this. This is my area. This area I can area A. Now normal force F1 by A. So F1 is what? F1 is F is F1 cosine theta. So F1 is F by cosine theta. So normal force is sorry, this is not right. So F1 by A and shear, and then we can write F cosine theta by A. The shear force, shear stress, sorry, is defined by tau is shear force by area. The shear force is F2, say area we denoted by A. So F2 is F sine theta by A. Now let's solve a problem. Um, in this problem, so let's remember is subject to force F 30 kilonewton. Its other end is fixed, and this length is 3 meter. Okay, this length is 3 meter, and this length is 5 meter. So what is the stress in a plane which is angle theta to the horizontal? So if I draw a free body diagram of this, so this is the plane which is cut with a theta degree angle. So this is my theta, and so this is the force F, and this is the force which is normal to this plane. So that is 90 degree, and this is my theta F2, sorry, F1, and the other force is working along the direction of this inclined plane F2. So the normal stress sigma is equal to F1 divided by area. Now this area is, if this area is A, if this area is A, this inclined area actually A by cosine theta, this inclined area. Okay, so sigma, we know F is what? So this is F1 actually. So F1 is equal to F cosine theta and A cosine theta. Now, so sigma is equal to F by A cosine square theta. So if theta is equal to, say, if theta is equal to 45 degree, so F is 30 kilonewton, F into 10 to the 3 Newton, and A, we know this A is what? This A is 5 meter by 3 meter, 15 meter square. So A is gonna be 15 meter square, and cosine theta, that means cosine square 45. Okay, so now let me calculate this, how much it's going to be. Cosine 45 square multiplied 30. So 1000 Newton meter square. That means 1000 Pascal. 1 kilopascal. Okay. Now the next is what gonna be shear stress. The shear stress is, okay, let me write it here. The shear stress tau is going to be F2 area. So again, this area is not this flat area. This area is this incline area. This incline area. So since it has an angle with theta, so it's gonna be A by cosine theta, and F2 is equal to F by sine theta. So F by A sine theta cosine theta, that means 30 into 10 to the 3 Newton, then A is equal to 15 meter square sine 45 cosine 45. Let me calculate this one. 45 into, so this is also 1000 Pascal. So, so this is, I introduce in this example the concept of normal stress and the shear stress. Again, normal stress is the stress which is caused by the normal force, and the shear stress is the stress which is caused by the shear force. So what is normal force? Normal force is the force which is perpendicular to the plane, and the shear force is the force which is parallel to the plane. So I hope you understand that concept. Thank you very much for watching.